Determining the HVAC load for an office involves several approaches, ranging from standard methods to detailed calculations. Firstly, consider standard methods such as those provided by ASHRAE. ASHRAE Standard 62.1 provides recommended ventilation rates for indoor spaces, basing its recommendations on occupancy, activity level, and indoor air quality requirements. This standard helps determine the necessary fresh air intake and exhaust rates, which significantly impact the HVAC load. Secondly, ASHRAE Standard 90.1 offers energy efficiency guidelines for HVAC systems in commercial buildings, and these guidelines include calculation methods for heating and cooling loads. This standard is crucial for ensuring that the HVAC system is not only effective but also energy efficient. Rule of thumb methods offer a simplified approach for estimating HVAC loads. For office buildings, a common rule of thumb suggests 25 to 40 British thermal units per hour per square foot, which translates to approximately 30 to 50 watts per square meter of floor area for cooling. For heating, the rule of thumb is 4 to 6 British thermal units per hour per square foot, which is about 5 to 7 watts per square meter. For example, if you have an office area of 180 square meters, which is approximately 1937 square feet, the estimated cooling load would be between 4,500 and 7,200 British thermal units per hour, or 1320 to 2110 watts. The estimated heating load would be between 720 and 1152 British thermal units per hour, or 210 to 340 watts. The most accurate method for determining HVAC load is to perform a detailed calculation based on the specific building design and occupancy. This involves considering several critical factors. The first factor involves the exterior walls, including their area, insulation, and orientation. Walls with poor insulation or those facing direct sunlight will contribute more significantly to the heating and cooling loads. Another factor involves the roof, specifically its area, insulation, and solar heat gain. Like walls, a poorly insulated roof or one exposed to significant solar radiation will increase the load. The third factor is the windows, considering their area, type, and glazing. Single-pane windows, for example, allow more heat transfer than double-pane windows or those with low emissivity coatings. Occupancy is another critical factor, including the number of people, their activity level, and the equipment usage. More people and more equipment generate more heat, increasing the cooling load. Ventilation requirements also play a significant role, particularly fresh air intake and exhaust rates. Adequate ventilation is necessary for indoor air quality, but it also impacts the energy required to condition the air. And the climate data, which includes temperature, humidity, and solar radiation, must be considered. These factors vary significantly by location and time of year, influencing the HVAC load. Several software tools and online calculators are available to assist with HVAC load calculations. For example, Energy Plus is a free energy modeling software from the U.S. Department of Energy. This tool allows for detailed simulations of building energy performance. There are also online tools like the HVAC calculator, which provides quick estimates based on simplified inputs. Proprietary software such as TrainTray 700 from Train Technologies offers comprehensive analysis capabilities. Remember that the actual HVAC load may vary depending on factors such as built-in construction, geographical location, and operating schedules. Consulting with an experienced HVAC engineer for a precise determination is always recommended.